Sir, done.
Bismillah Rahman. Okay, Bismillah Rahman Rahim. This is a question of October 2019, 41 variant, and question number 6. A particle of mass 0.4 kilogram released from rest. So it means mass is 0.4 kilograms and starting speed u is 0 and height is s to travel 1.8 meters above the surface of water in tank. There's no change of speed when particle enters the water. Normally in the common life, when particle enters inside, so speed changes. For example, this is a cylinder. So when water, this is a water level, I show you in different color. Water level, when particle hits, okay, and after hitting, it's traveled downwards. So common sense, this changes velocity, but he said no change. He said no change. Okay, the water exerts upward 5.6, but the water exerts upward force. This is called a friction in water. So friction water, so very clear. And the one it is in the water, clear. So I will call as a in water, in water, in water. So friction is what is actually 5.6 in water. Find the velocity of particle instant when it reaches the surface of water. So we need to find this velocity. So this velocity is my first concern. So you know that, and falling under gravity, so g plus 10. So first is easy. So you know it is a very clear 2as is equals to v square minus u square. 2 times to gravity plus 10, s is 1.8. Last velocity is my concern. We have to find. So it's become 1836, it's become 6. Because 18 times 2, 36, and 36, I got a 6 meter per second. So it is a very clear, alhamdulillah, Rabbil Alameen. Okay. So after this first part done, so first part is over. Part number 2 is very interesting. Find the time it takes instant when the particle enters the water until it comes to rest in the water. Okay. It means it enters inside and speed here 6, here also 6. So he said that, I repeat, find the time it takes instant when particle enters the water until it comes to rest in water. You may assume the tank is deep enough that particle does not reach the bottom of the tank. Okay, so it means this, maybe it is not stopping there. Okay, let me erase it and let's make a plan. Maybe it stops here in the middle somewhere. So at this point, velocity confirmed equals to 0. Okay, now interesting part. This is I'm giving a title here. Okay, motion in the water. Motion in water. So motion in water is a title, and this velocity v becomes u. I'm writing u is equals to 6. Last velocity is 0 because it rests. Last velocity. Okay, and the only interesting part, what we have, how to find it. So as we don't know how much it will travel, so what is my concern? Time is my concern. Okay, and let's talk about when a particle, this ball going downwards, so weight, mg, weight component, and backward we have a friction component. Why? When it's traveling in water, so weight is pulling downwards and friction is upward. So what is the formula? Normally we use net force is equals to ma. So mg's mass is 1.4 into 10, it becomes 4 minus friction. Friction is 5.6. So 5.6 is equal to mass 0.4. Acceleration is my question. So if I check it, so 4 minus 5.6 and divided by 0.4, and I get the negative 4. So deceleration of 4, very clear. So I think I have acceleration, I have velocities, I can find easily time. So v is equal to u plus 18, and v is 0, u is 6, acceleration -4, and time is question, which we got it. Alhamdulillah, Rabbil Alameen. And let me check, it's become 6 divided by 4, so it becomes 1.5 seconds. But let me read. Find the time it takes from instant when particle enters. Sometimes he says start from the top. So he enters, talk about until it come to rest. So alhamdulillah, this part is very, very clear. Now we'll go for a sketching part. So now next page, what the question he is saying, question is sketch the velocity time graph for the motion particle from the instant at which it is released. Oh, it means from top until it come to rest in water. It means it is 3-mark question. So, so we have to talk about until it come to rest from the top. So let's start. So, so this point is final point we have. Okay, and let's start how we can get this part. Okay, so let's try to get it. First of all, you know very well, we have to go for the sketching part. And let me tell you one thing. Whenever we sketch velocity time graph, we need 2 things. Naturally, we're plotting VT graph, so time here, V here. So we need every moment velocity time coordinates. Okay, like we can say what is the time, what is the velocity, each point. If able to get these values, so really it's not a hard job at all. We can get easily. Let's start. So when you talk about this motion, there are 2 motions out there. One this, one this. One is a speeding up and one slowing down. So there are 2 things out there. So one thing, let me click data. Click data. So I think starting from here, I say when time is 0, velocity is 0. One thing is clear. Second, when time is how much time? Oh, I don't know time. Okay, I can find time easily. Okay, so the time when it hits the ground, hit the water, I must need. So that is why. So I think using this data, I can find the final time even. So let's find V is equal to, okay, first I find the velocity. So V is equal to U plus 80. Last velocity we got a 6. Starting speed is it is 0. So let's find it. So 6 is 0, and acceleration, it's a falling under gravity 10. So its time becomes 0.6 seconds. Okay. So let's discuss now step by step. Okay. Number 1, when time is 0, velocity is 0. Number 1 done. 1 point. Number 2, when time is 0.6, time is 0.6. Velocity is 6. Number 2 done. Okay, you can see that velocity 6, time 0.6. Okay, after entering water, what happens? It slows down. Okay, and it slows down, and last velocity is 0. Okay, so we must need this time as well, and we got the time 1.5. So if I in 6, it means 0.6 and this 1.5 add. Why add, sir? Because when it enters this 0.6, we have it. After that, it will take 1.5 seconds. So 1.5 and 0.6, it means 2.1. And velocity again becomes 0. So I think you got the idea. Now I'm going to make it. I click my all data, and throughout it is a we can say that positive, no velocity negative. So I will make it like this. Okay, and values along x-axis, highest is 2.1. So 2.1, how I divide this x-axis? So because I need 0.6 also, so I think if I make it 0.22, 0.2, 0.4, 0.6, 0.8, 1, maybe it's trouble for us. Okay, I make it a little bit short intervals. Okay, 0.2, 0.4, 0.6, 0.8, 1, this is a 1, 1.2, 1.4, 1.6, 1.8, 2, this is 2. And naturally, it is not hard to check where is a 2 point. So this I'm writing here, this 2.2. So 2.1 is somewhere naturally in the middle of somewhere. Okay, all right, I make it here. This is a 2.2. And what is the highest velocity? We have a 6. Okay, Now here I make it my own wish. So for example, 1, 2, 3, 4, 5, and 6. Okay. All right. So I think easy now. So first of all, because it's a constant acceleration, so constant g is throughout same. So we can make it when time is zero point 0.6, velocity is 6. What is that? So I just show you, you can understand. Zero point 0.6 line is this. Wait a minute. Zero point 0.6 line is this. This is 0.6 line. And where is 6? This is 6, approximately. So this point I have it. Okay. I erase the lines. So I'm going to make it. This is our first part is very clear. Okay. After that, it slows down and it has a still a constant acceleration. You have -4. Okay. And it decelerates until it comes to 2.1. So let's see 2.1. And it is very clear. I will join with this with 2.1. So this 2.1, because I think this is 0.2, each gap 0.2, 0.2. So this 2.2 here, but I need a 2.1. So you can see that this is first acceleration, this is acceleration, and this is deceleration. All of you know, these are positive gradient and these are negative gradients. And I discussed before, even the previous clips, okay, that this is a positive T is this kind of lines, and negative T we get this kind of lines. So that is why, time, okay. But here, the same thing, acceleration depends upon the time. So that is why. And label it now. And again, this question will completely over. Here we have a time in seconds. And here we have meter per second. Okay, so we have finished. Alhamdulillah Rabbil Alameen.